Here's review for the next quiz on sections 3, 4 through 3, 7. So the first section here is graphing the function and stating the domain and the range. You also should be able to state the transformations from here. So when in doubt, graph it out. Take this function, y equals 3 square root x minus 5. Make sure you come out from under the root and do +1 and graph it. You'll see that it looks something like this, where x goes to the right 5, 1, 2, 3, 4, 5, and up 1, and then it's going to be a stretch, right? So right 5, up 1, and a stretch, okay? This starting point right here, it's the point 5, 1. So your x value is 5, your y value is 1. Domain is x, range is y. So that point for a square root function tells you the starting point is 5. So for domain, it's going to be 5. It goes forever to the right, so it's going to go to infinity. Okay? For range is how high, so that's your y value. What's your y value at that point? It's 1. And then it goes up forever. So 1 to infinity. Square brackets around the numbers, round brackets around infinity. Okay? Before I even graph this, I notice it's a cube root. So I know cube root goes forever in both directions. So automatically I'm putting domain and range here. Then sure, you can graph it. I know this is a compression, meaning it's going to push the cube root function closer to the x-axis. This moves that vertex point, so that turning point, right 1, and this moves it up 3. So when you graph it, the parent function started at 0, 0. So if this goes right 1, up 3, this is going to be your starting point now. I mean your vertex point. It's trying not to use it, okay? So it's going to go like this, and it's some type of compression, so it's a little bit thinner. All right, so you get the idea, but you're using your calculator. All right, on to the next section that says solve the equation, check for extraneous solutions. So because it says solve, I know I need to get x by itself, right? So to get rid of the square root, I need to square a square root, right? If I do it to the right side, I have to do it to the left side. When you square x minus 2, it's really multiplying out, so it's like foiling, right? So I'll just write that stuff, and then below it, x times x, x squared, minus 2x, minus 2x, plus 4 equals 2x minus 4. Because on the right-hand side, the square and the square root canceled. When I subtract 2x over here, that cancels. Add 4, it'll cancel on the right. I'm left with x squared minus 6x plus 8 equals 0. This has to factor. Always comes back to good old factoring, right? X and x is the first term in each parenthesis. It has to multiply to a positive 8, which tells me the same sign, and add to a negative 6, so both negative. What multiplies to 8 and adds to 6? 4 and 2. Not done yet because it says solve. So x minus 4, solve for x. I'm running out of space there, so I'm going to put up here. X equals 4. X minus 2 equals 0. Add 2 to both sides. X equals 2. If I plug it back in, plug in 4 here. 4 times 2 is 8. 8 minus 4 is 2. And 4 minus 2 is 2, so it works. So that's a check. 2. 2 times 2 is 4. 4 minus 4 is 0. Square root of 0 is 0. And 2 minus 2 is 0, so that one also works, okay? So please check. You don't have to write out your check, but you should always check. All right, in number 4, I need to get rid of the 1/4 here. To get rid of a 1/4, you multiply by the reciprocal. So multiply by 4 here and here. So on the right-hand side, the 4 and the 1/4 cancel. I still have 2x plus 6 equals, to the 2/3 equals, now I have 4 times 4, 16. To get rid of the 2/3 in the exponent, I multiply by the reciprocal, 3 over 2. They cancel on the right-hand side, so I'm just left with 2x plus 6. When I type in my calculator 16 to the 3/2 power, you should get 64. okay? Then I have to subtract 6. So 2x equals 58. Divide by 2. X equals 29. Double check by plugging it in. 2 times 29 plus 6 to the 2/3 power times 1/4, and make sure that equals 4. In number 5, I have a cube root on both sides, so I'm not going to square it this time. I'm going to cube both sides, but it doesn't really matter because they cancel out on both sides. So I'm left with 3x plus 10 equals 5x minus 6. This is a linear equation, so I need to get my x's on the same side. So I subtract 3x from both sides. I need to get my numbers on the other side, so I add 6 to both sides. 10 plus 6 is 16. 5x minus 3x is 2x. Divide by 2. X equals 8. I check on my calculator. 3 times 8 plus 10, cube root it. 5 times 8 minus 6, cube rooted. It will work. Oh, I forgot to check that one. Okay, so let's move on to the newer stuff. Find the inverse. I know the inverse means I have to interchange x and y. Right now I don't see a y, so I'm going to write over my f of x and make it a y. Okay, so first step, change them. So instead of y equals, it becomes x equals. On top of the fraction, instead of 5x plus 3, it becomes 5y plus 3. On bottom, you still have 7. Now solve for y, just like we always do. So I have to get rid of the denominator first. So multiply both sides by 7. On the right-hand side, the 7 in the denominator cancels. You're left with 7x on the left-hand side. So now I have 4y plus 3 still. Okay, keep going, solve for y, subtract 3. So 7x minus 3 equals 5y. Divide by 5. And then at this point, I would just leave the 7x minus 3 over 5. You don't have to rewrite it. The only thing is my original notation was f of x. So when I do the inverse, I write f of x to the negative 1. And then I have on top 7x minus 3 and on bottom 5. Okay, so that's all. If it asks you to find the inverse, you're writing the equation, right? So once you interchange your x and your y, you get y alone, you're done. That's all you have to do. This one says verify their inverses by showing the composition is just going to be x, right? So I'm going to start with f on the outside, gx inside. If your outside term is f, then that means you need to write f's equation. Okay, now you need to take g of x and put it in for x. So this is 3. Instead of an x there, replace it with g of x, which is x plus 1 over 3. You still have the minus 1. Okay? You're not balancing two sides of the equation. Just keep on going here. The 3's cancel. So now I have x plus 1 minus 1. Now the 1's cancel, so now I'm just left with x. So I have verified. You do the same thing going the other way. Like I told you before, I'm not going to trick you with it, and I don't have that much space, so I'm just going to do it the one way. Okay, let's look at this one. We'll do the same thing. We'll just do the f on the outside, gx inside. So if I'm using f's equation, that means I have 4th root x on the right. Okay, now I'm going to replace g of x. I'm going to put that in where x is, right? So I still have 4th root. And instead of an x there, what is g of x? It's x to the 4th. What happens when I do a 4th root? They cancel. I'm just left with x. Okay? If we did it the other way, which I don't really have space to do, you would just put g on the outside. So g is x to the 4th. But then I replace x with 4th root of x, which is what f is. And then to the 4th power. If they still cancel, you're still left with x. Okay. Okay. The other thing is graphing and telling whether the inverse is a function. So I would just take this, put this into your y1, type 3, x to the 3rd minus 5, and graph it. It'll be something like like this-ish, right? We'll switch colors here. If I draw my horizontal lines, it only ever hits once. This is where it gets a little ambiguous. People think, oh, isn't it hitting more than once there? It's not. It'll be very distinctive if it's hitting more than once, okay? So it only hits once. So yes, it passes, right? The horizontal line test says it can only hit once. So tell whether the inverse is a function, which is why we use horizontal line. So yes. Why? You can just say passes horizontal line test. Or instead, you could say hits horizontal line only once or something that makes sense to you. Okay, just be able to explain. Even your picture, like even this picture is enough explanation for me. All right, then I look at the next one, 1/4 x squared plus 1. I type it into my y equals and I graph it. It's a wide parabola. So if I were to do my horizontal line, it hits once, twice. So the inverse is not a function. You can just say it fails, the HLT, or you could say hits horizontal line twice or more than once, right? All right, the last one here, I already told you this now that this is going to be a bonus question. So you can get over 100 on this quiz. It's finding the inverse. So the first thing I do is I rewrite it. X equals 1/27 y cubed. The first thing you need to do is get rid of the 1/27 because you need to get y cubed alone. So multiply both sides by 27. And now I have 27x equals y cubed. Cube root y equals cube root 27x. Now technically you can do the cube root of 27. So a cube root of 27 is just 3. Okay, so that's like what you learned. I guess I shouldn't do that part yet, sorry. In the last chapter, we talked about how to simplify this. So doing the inverse, great, but then simplify. All right, so then when I finally rewrite it over here, I just do f of x inverse equals 3 cube root x. Okay, all right, that's all. Feel free to go back and redo any of these problems or more from the notes or worksheets posted and see me if you have any questions.